The capstone project that we analyzed was the low-cost cocoa butter press. The problem that our project was addressing was the fact that cocoa bean producers get a low income due to the cocoa butter being grinded in other places. And by having a low cost and low maintenance machine that can be operated by anyone, allows the producers to achieve a higher return on investment, which is what drew our attention to this project. The design choices that shaped the final product. The heating reservoir system was a great way to soften the beans before they were pressed, requiring less force from the machine. And having a canister with small holes for the liquid butter to easily flow into the collection tray efficiently. And lastly, the final design is adaptable, modular, and compact, and has an easy process with high output potential.
Reasoning behind designs. The heating of the beans causes less force on the press, which allows the frame to be lighter and more modular. The separation of cocoa butter and solid parts left over from the cocoa beans was a manual task on previous iterations, so having the canister automatically filter out the liquid butter saves a lot of time. Also, keeping the modular design makes this piece very easy to maintain, along with ease of use for farmers who are inexperienced with heavy machinery. And as you can see from this image taken from the Capstone team's project, the canister experiences a very low amount of force, meaning it will be able to be durable when pressed. Change in strategy. We reconsidered the press system, as there seemed to be many pieces that lacked functionality, and this creates unnecessary complexity and makes it harder to use for farmers. We also prioritize easy operation while still maintaining the press force, stability of the frame, and output required for efficient production of cocoa butter. We also slightly changed the interaction between the press and canister to keep the same press surface area with less material being used. As you can see from these images, on the left, the Capstone team has two extra cylinders at the top where the hydraulic press is installed, and we decided to get rid of this to make it a little more simple and easy to use for farmers. Additionally, their hydraulic ram maintains the same size and diameter throughout the entire assembly, whereas ours is a little thinner where it connects to the top part and then it inserts into a wider surface area cylinder that actually presses through the canister.
As for application, our project made minimal changes to the original design of the Capstone project, so the stress predictions and heat predictions from the original project should match ours. Additionally, the functional animation shows the function of our project as being a press that goes down when the handle is engaged, and there's a tray that slides out easily to show the cocoa butter. These provide a visualization for the functionality of the project and the practicality, showing that it's going to be effective in pressing cocoa butter. As for the reflection, design decision making should revolve around creating an effective final project, but the most important part is making sure that it fully serves the intended customer purpose above all else. This means that certain projects have to be sacrificed. For example, we remove part of the pressing system to make the product easier to operate and assemble for farmers with no machine experience. If you face trouble with the design decision, the first thing you should think about is what's going to benefit your target audience, as pleasing them should be your number one priority. As for